Welcome to another weekly session where I share my experiences from over 6 years of helping companies implement modern data and AI solutions. And these sessions are always going to follow more or less the same format, where first I'm going to answer some questions from my YouTube comments, and then after that I'm just going to talk about some other topics that I've been thinking about recently in my work as an independent consultant. And what I'm going to talk about today is how you can make sure that AI agents don't accidentally leak your private data or the private data of your customers. But before that, we have some great questions to answer. So I'm going to go here to my community tab on YouTube and then start answering these from the top. And the first question is from Khalid. What are your thoughts on N8N for building agents? Videos have been awesome. Thank you very much. So for those who don't know, N8N is a low-code automation platform, a bit like Zapier or Make.com, where you have this kind of a drag and drop interface for building workflow automations, and now even like simple AI agents. And so what are my thoughts? I think it's a cool platform. I have played around with a little bit myself, and I have actually used it with a few clients, mostly for prototyping, because it basically allows even non-technical people to get started solving their own problems with automation. And I think that kind of approach is really valuable and really important. And something like N8N can really help you drive that kind of a bottom-up conversation, because you can make the conversation much more concrete. You aren't just talking about sticky notes of what the solution might look like, but the people themselves, either individually or with some support, can actually get started building like a first rough version of what the solution might look like. And then you can use that as a starting point to kind of figure out, bring some technical expertise and take it a little further to figure out what the actual more proper production system might look like. So yeah, that's where I found personally the most use from this kind of platform. But that's also not to say that you can't build actual like live useful systems on N8N. Certainly a lot of people are doing that, and that's completely valid. Personally, I don't use it that way for my actual development work, because the way I see it, it's useful for people without a software engineering background to get started building these relatively simple automations and agents. But if you do have that background of working directly with code, like I do, then there's basically only advantages to doing that instead. Specifically, two pretty big limitations that N8N has from my point of view are the lack of proper version control and automated testing, which means that you can't have this kind of a controlled process where you can easily review the changes made to the system across potentially multiple developers. You can run some automated tests to make sure that nothing breaks in the system as a result of these changes, and then only after having passed that kind of a review process, then you can automatically deploy new versions of your system to your live environments. And so the fact that you can't really do this in N8N, they do have like some simple Git-based version control system, but it is quite limited compared to the, let's say, real thing. And so that's basically a deal breaker for any kind of more complex or large scale system, especially if you have more than one developer working on it, then this kind of stuff really starts to matter. So yeah, that's why I don't personally use it for my development work on agents or any other systems. And nothing bad to say about the platform. Like I said, it's still very good for non-developers and relatively simple systems. And when I say simple, I don't mean that as a bad thing. Simple is beautiful. And in a lot of cases, even these simple systems can drive a lot of business value. But just the systems I tend to work on are usually a bit more on the complex side, involving a larger development team, and also often involving some like front-end, some interface development, which of course you also can't do on N8N. It's only for the back-end automation work. But yeah, very cool, very useful platform as long as you understand some of these limitations. I think it's good. I think it's great. The next question from Darvzify. You mentioned you use Langfuse to monitor and improve the agent. Can you show more detail on how that works? Working on a similar agent in Teams instead of Slack. I appreciate your input. Thank you for the question. I love this question. And so here I'm talking about a recent project of building an AI agent integrated into a client's Slack workspace. And so what is Langfuse? Well, Langfuse is a platform for managing the traces of your AI applications. And what a trace is, well, it's the journey of a single request through your entire system. So this is a trace. This is one trace. So you have a single request. It's a question from the user. And then you have multiple events or multiple steps. And these steps would be the different things that your system or your agent does in order to answer the question. So, tool calls, retrieving information, etc., etc. So multiple individual events, and together these events form one trace, right? And the point of having traces is that it allows us to better understand the ways in which our system is failing. So classic example, you ask the system, what was our total revenue for the last 2 months? and it gives you a wrong answer. And if you are just looking at that wrong answer in Slack or whatever the interface is, you really have no way to tell why the answer it gave is wrong. It could be wrong for like 50 different reasons. But if you can look at the traces, then you have a lot more detail and you can see exactly where the issue is coming from. So for example, maybe you can then see that the agent doesn't even look up the information in your financial database. It just hallucinates some random numbers, which are obviously going to be wrong. So then in this case, the issue is probably that the agent either doesn't even have the tool to look up information in the database, or it does have the tool, but the system prompt or the tool description doesn't sufficiently explain when and how it should use that tool, right? Something like when a user asks questions around financial information, then you should use this tool. Or alternatively, maybe you can see in the traces that the agent does correctly look up information in the database, but the numbers it gets back from that database are just wrong. So then in this case, it's maybe a totally different type of issue. It's a data quality issue in your database. Or maybe you can see that the agent does correctly look up information in the database. Those numbers are correct. But then when it tries to add those numbers together in order to get the total revenue that the user is asking for, then you see that there's a mistake happening there in that math operation. And if you're using a slightly older or smaller model, then you'll know that those are famously not very reliable at doing math. So then in this case, the solution would probably be to give the agent also some kind of calculator tool so that it can run these math operations in a more deterministic and more reliable way. And so I could go on, right? There's so many different things that could cause these kinds of systems to give incorrect answers. And all these different situations require a different fix to the system, right? You can tweak your prompts and your tools all you want, or you can change to a bigger, more expensive model. But if the issue is somewhere in the pipeline that's updating your financial data, then of course you aren't going to see any improvements. And so that's how it works basically. You look at your traces to figure out where and how the system is failing. And then you use that to inform the kinds of improvements and the kinds of fixes you do to your system. Now, additionally to the traces, Langfuse also allows you to collect evaluation metrics, or evals for short, for your system. So these are just any kinds of numerical KPIs to measure how good the system is. This could be as simple as like user feedback, thumbs up or thumbs down, as 0 or 1. You could also use different kinds of LLM as a judge metrics, which is just using another LLM to evaluate and score the responses of the main system. Right? So all kinds of things you can collect. But the reason this is important is that this then allows you to start improving your application more systematically. So you aren't just stuck manually looking through these individual failures, like with the example I just showed you. That's a decent way to get started, but it's not really sustainable after you start to have, hundreds or thousands of traces and users for your application. So then these evals will allow you to see like bigger picture patterns. For example, maybe you can see that all your questions related to financial information have much lower scores on your evals compared to the other topic areas that users ask about. So then that will tell you that this is something where you should probably dig a little deeper in. And then on Langfuse, you can also like filter your traces to only be looking at those that are related to financial information, and then drill deeper into those traces specifically. And then you can also see over time how your metrics will hopefully improve over time as you iterate on your system and make these different improvements. So that was a lot of stuff, but hopefully it answers your questions around the role of Langfuse and how it's used. It's certainly not rocket science, but there is also quite a lot of stuff that goes into setting up good tracing and good evals. And this is really the foundation of how great AI applications are made, and I'd say it's the biggest thing that people still don't quite understand. So yeah, it's a good question to be asking. Highly recommend you wrap your head around this, implement some tracing and evals for your agent, and really start prioritizing this stuff in all your projects, and you'll be ahead of the majority of people out there. Next we have Aruna3945. When we have a huge number of documents, using an LLM to create entities and relationships, so we're talking about graph data modeling here, doesn't seem like a good idea in such a case. Yeah, I talked about the challenges involved in using LLMs with graphs just here in my last video. And it's not exactly related to the number of documents you have, but it is true that the more documents you have, the more data you have, the harder these challenges like deduplication become. So you're basically right. I don't think it's a good idea to do with a huge number of documents. I also don't think it's really a good idea to do even with a smaller number of documents, as I explain in this video. And next, thank you for the tutorial. It's working for a single simple table. Have you tried combining time series data of multiple tools, analytics billing, complex warehouse, and successfully getting results from text to SQL? via prompt engineering? Not really. The largest or more complex database where I've done this kind of text to SQL work was only around five or six tables, around 10 columns each. So, only 50 to 60 columns in total. And that also did include time series data. But yeah, it wasn't really like a super complex warehouse with like 100 tables or more. But I definitely think it can be done with the current models. It's mainly that at a certain size, you probably can't just feed the LLM the entire database schema without causing the LLM to become confused and losing reliability and just getting errors in the SQL generation. But all that really means is that you need to implement some kind of routing logic based on the user intent. So depending on what the user is asking for, you only pass the parts of the database schema to the context, to the LLM context that are relevant for that question, right? Because if you have a complex warehouse with like 100 tables, it's not like you're ever going to be querying all 100 of those tables together. Usually most questions that users ask are going to be answered just by joining 2, 3, maybe 5 tables. So you just need to implement this kind of more dynamic prompt building in your text to SQL. But I definitely don't doubt that you can do something like this for a pretty complex warehouse at this point, just because of how much better the latest models have gotten at generating SQL in general. So that's our Q&A for the day. Just as a reminder, if you have any question that you'd like me to answer, whether it's technical or business related to AI and AI adoption, you can just leave it in the comment below any of my recent videos, including this one, and then I'll answer it in a future video in as much detail as I can. Now moving on to our other topics. I said I would talk about the AI agents and their security, specifically around their potential of leaking private data. And this is a topic that I think doesn't get quite enough airtime in the conversation. And I think there's a good chance that in the next 6 to 12 months, we'll see a lot of cases of these AI agents leaking private data. And the reason for that is this concept of a lethal trifecta in this great post by Simon Willison, posted just a couple of months ago. And the core idea here is that if you simultaneously give an LLM-based agent these 3 capabilities, then you're very likely to expose yourself and your private data, like your emails or documents, to being leaked. And these 3 things are exposure to untrusted contents, access to private data, and the ability to externally communicate. And you can probably start to imagine how these 3 things combined can be problematic. But to show you an example, this here is basically what we are talking about. If you ask this kind of an agent to summarize a web page, and then that web page has this kind of a harmful instructions embedded in the content, then there's a good chance that the LLM or the agent will actually end up following these instructions instead of your original instructions. And that's just because of the way these models work. They can't reliably distinguish between instructions given by the user and any instructions that might be accidentally fed to it as part of some external content. And these kinds of attacks or vulnerabilities are referred to as prompt injections, which you may have heard about. And so in this example, the web page here, this here is the untrusted content. And then if this agent or this system also has access to some private data, as well as the ability to externally communicate, for example, by being able to write emails automatically, then there's a real possibility that this kind of an agent can leak your data. And so right now, why I think this is relevant is that although it's still quite early, now there are increasingly a lot of people and companies building out exactly these kinds of agents that fit this criteria, right? The typical simple example might be some kind of inbox management agent that can read your emails, maybe do some tagging and automatic categorization, and then maybe it can also reply automatically to some of those emails. And this makes sense because the models have gotten good enough where they can actually do this kind of work quite well and quite reliably. And nobody exactly loves dealing with their inbox. But already in this kind of a simple system, it's actually very easy to check off all these 3 boxes, right? Because anybody can send you an email with any kind of injected content. So that's the untrusted content right there. The emails themselves are private data that the agent has at least some access to. And then finally, if the agent also can automatically send emails without user confirmation, then that already puts you in the danger zone, let alone if this agent is also connected to something like your calendar or your Google Drive or other sensitive data. So now that you hopefully understand the risk, and what should you do about it? Well, for starters, you can just sear this image into your brain. And make sure that whenever you're building these kinds of agentic systems, that you just avoid checking off all of these three boxes, right? So taking this example of the inbox management agent, there's a couple of things you could do. First, most simply, you could just remove this external communication piece. So removing the agent's ability to send out those emails. Maybe instead you only make it so it can create draft responses that you still need to manually review and send. So you add a little bit of friction, but this way you can entirely avoid this risk, because again, having one of these is fine, having two of these is fine. It's having all three at the same time that you want to avoid. Or alternatively, if you really do want the agent to be able to send these emails, then you could also look at ways to filter and block this incoming untrusted content. So for example, you could do some text matching to look for things like email addresses or other signatures of these prompt attacks in the incoming messages. Or for a more intelligent approach, you could also just use an LLM to look at the incoming messages to try and identify any of these attacks. That is very commonly done, and it can be very, very effective. Now, unfortunately, it can never be 100% bulletproof if you are using an LLM, because by their design, these prompt injection attacks are made to exploit weaknesses in LLMs. So if you are using this kind of an LLM-based filter, there is a chance that a well-designed attack could also bypass the filter in some maybe rare cases, but nonetheless, and then make its way to the main system where it can cause some harm, right? But maybe you can use some combination of some text-based filtering and sanitizing of the emails combined with some LLM filtering. You could also do some email whitelisting, so only letting in emails through to the agent that are from people you trust or maybe domains you trust. But in practice, that's something you need to figure out for yourself based on your use case as well as your risk tolerance. So using the proper combination or stacking of these different filters to achieve a good balance of flexibility and security so that the agent is able to achieve the task that it was built for, while then also sufficiently managing the risk by your standards of what's an acceptable level of risk for you. Now, a final note I want to add to this topic is that for better or worse, building these kinds of simple agents is now becoming more and more easy, and specifically people are very excited about things like MCP and also platforms like N8N that I talked about before, because they make it really quite straightforward to connect these LLMs to all kinds of different systems with very little technical effort and understanding of what's actually going on. And while I think this is generally a good thing and helps with the adoption and spread of the technology, I do think it also makes it easier to end up with a lot more of these rather insecure systems, because you get a lot of people who are more likely to just care about whether or not something works in the immediate short term, as opposed to also ensuring that it's robust and secure in the long term. But hopefully these points will help you avoid that mistake, whether you are building these agents yourself or having someone else build them for you. And that's all I have for today. As always, I hope you found it useful. Drop your questions down below and I'll see you next week.